Welcome back everyone to another episode of the Doom series, and in this video we are gonna do some optimizations regarding our floor and ceiling textures. Alright guys, so we'll begin by opening up our flat texture.h. Actually, let's open up render.c first, and the basic idea is that it is going to be much more efficient to use texture arrays instead of using separate textures for each of our flats. So for that we'll first of all change our shader a bit. So inside of render.c you can see that I have modified my fragment shader so that now it consists of a uniform sampler 2D array. So earlier it just had a uSampler 2D, now it has got a uSampler 2D array, and that's we are going to use that array. And we have also got another uniform here for the texture index, and this uniform we'll use to actually specify what texture index we want to access. And if I go here, you can see that when we are setting our fragment color, we are using a vector 3 here. Now the first two elements are of the actual texture coordinates, while third one is the index of the texture. So yeah, this is pretty simple, and yeah, we can access multiple textures using just a single array this way. The next thing we'll do is that since we have got another uniform, we'll create another location variable for this, and we'll expose another method. So if I open up render.h, we have got another method, another function here for setting the texture index, and you can see it's implemented here. And we just use gl uniform 1i with the texture index location, and we can get the texture index location here just by using gl get uniform location. Pretty basic stuff. Now for actually generating a texture of this kind, let's open up flat texture.h. Inside of here we have got a single gl uint function here, which returns a gl uint and takes an array of flats with the number of flats as well. And this function will generate a single texture array, 2D array for a 2D texture array for actually accessing with OpenGL. And if I open up flat texture.c, in here we now replace all of the gl texture 2D with gl texture 2D array. And in here another thing we'll do is that first of all we need to create the appropriate storage, and since our textures are gonna be not modified, and anyway we are not going to modify the size, we are going to use gl text storage 3D to actually allocate the appropriate storage for a texture. We are going to tell it that we have got a 2D array. We are going to tell it that we only want one level of detail. The internal format is unsigned 8-bit integer, and then we are going to pass it our flat texture size for the width and height, and then for the depth, which is the actual number of elements in that array, we are going to use number of flats. Then we are going to go over each of the flats, and then we are going to use gl text sub image 3D to set each of the images inside of that correctly. So we are going to use 0 0 1 here. So this first one is the actual LOD, which is going to be 0, of course. Then we have got the x and y offset, these are also going to be 0, and the z offset, or in other words the index of the array, is going to be I. Then for the width and height it's going to be flat texture size, while for the depth it's going to be always 1. And then we have got our format just like we had earlier, red integer of unsigned bytes, and then of course we pass our flats data of the current flat, and that generates those correctly. And if I open up engine.c, I'm going to close all of these here, and inside of engine.c you can see that we have got a static gl uint here, a flat texture array. Instead of having an actual array of textures, we have got like a single texture now. And if I go here, you can see that now we just create this array like that by using generate flat texture array, and we don't do anything else. So that works quite well, but of course we need to change our render function as well. So inside of render we set our texture to 0 when we're drawing our walls. Then when drawing our floors, we are going to set our texture to flat texture array. After that we are going to go ahead and start actually using that. So for this we first of all create two integers here, floor texture and ceiling texture, so that we can access the nodes texture easily. And we make sure that the floor texture is within bounds. If it's not within bounds, then that means that there's something wrong and we won't draw that ceiling or floor. Else we just set the texture index to this value, similarly for the ceiling, and then we draw it just like we were doing it earlier. And yeah, that's pretty much all of the changes we need. So if I go ahead and run make right now, what you should be able to see is that well, for starters, we do get our texture here correctly. And another thing you will notice is that where our sky was earlier, now it's there is like nothing here. So you can see that where the sky is supposed to be, we have got like completely empty space. And the reason behind that is, of course, our sky texture is actually outside of our flat textures, so it's outside of the bound, so we don't draw it. But apart from that, all of the other textures work correctly, and this is going to be a lot less load on the GPU. So in case of having multiple, a lot of textures, our game won't just break because doing a lot of texture switching. Because earlier we were using like one texture per flat, so we were switching one texture per every flat that we needed to draw. But now we are not doing that. Instead, we are just using a single texture and we are changing just a uniform variable. So that's much more efficient. Anyways guys, this is gonna be pretty much it for this video. I'll see you in the next one, in which we are going to look into the wall texture, so that's going to be pretty cool as well. So stay tuned for that. Make sure to like and subscribe if you don't miss the next one, and share this video with other people as well, and bye.